Hello everyone and welcome to our YouTube channel Quick Solvers. Here I want to find a plus b, where we have got this expression here, and well, we have the unknowns a and b only on the right hand side of this expression. Probably we need to focus on the left hand side and try to somehow simplify this. I think this is a good question for you if you are preparing for SAT or ACT, and its difficulty level is medium to hard. To find a plus b, I would like to write down some rules here. The first rule is that if we have a to the power of m to the power of n, we can rewrite this as a to the power of m times n. Okay, so this is the first rule. The second rule says that if we have a to the power of m times a to the power of n, this equals a to the power of m plus n. The third rule is that if we have a to the power of n times b to the power of n, this equals a times b to the power of n. Okay? And the last rule says that if we have a to the power of minus n, this equals 1 over a to the power of n. Or I can rewrite this as if we have 1 over a to the power of minus n, or let's say plus n, doesn't matter actually, this equals a to the power of minus n. So we can rewrite this rule in many different ways. So bearing these rules in your mind, we'll need to somehow simplify this expression here based on the rules that we have here. If we look at on the right hand side expression, here we have 3 to the power of a times 12 to the power of b, and well, I think we cannot further simplify this because the exponents, we don't know if a and b are equal or not, and the bases are not the same, so we should probably leave it as it is. And we should focus on the left hand side and try to simplify this. But in that, we need to somehow get something to this format, 3 to the power of a times 12 to the power of b. I mean, we should simplify this expression here and rearrange it, and then finally we get something like this. Then we can say, okay, we have a, we have b, then we can calculate a plus b. So bear that in mind when you are focusing on the simplifying of the expression on the left hand side. So let's start with it. Well, we have first term is 3 to the power of 1 over 4. I'll leave it as it is because it follows the format that I am looking for. It is 3 to the power of something. And then we have 3 to the power of 1 over 8. Well, this is quite fine. I will leave it as it is. Then we have 9 to the power of 1 over 32. Well, I should think here that can I write it as 3 to the power of something or 12 to the power of something? Well, we know 9 equals 3 to the power of 2. So then maybe if I have 9 to the power of 1 over 32, I can write it as 3 to the power of 2 to the power of 1 over 32, okay? And then following this rule, rule number 1, I can rewrite this as 3 to the power of 2 times 1 over 32, which is equal to 3 to the power of 2 over 32, and this equals 3 to the power of 1 over 16. So I can replace this one by 3 to the power of 1 over 16. The next term is 9 to the power of 1 over 64. Again, I need to think whether I can write it as 3 to the power of a or 12 to the power of something. Well, it's 9. Again, I can follow the same rule, write it as 3 to the power of something. So we have 9 to the power of 1 over 64. I can write it as 3 to the power of 2 to the power of 1 over 64. And this equals 3 to the power of 1 over 32. So I will replace this by 3 to the power of 1 over 32. Okay. So let's get rid of this. Now it's time to focus on the denominator. Well, for the denominator, we have 3 to the power of 1 over 2 times 4 to the power of 1 over 2. Well, these two, you see that the exponents are the same, so maybe I can follow rule number 3, which says since the exponents are the same, I can multiply the bases. That means instead of 3 to the power of 1 over 2 times 4 to the power of 1 over 2, I can write 3 times 4 to the power of 1 over 2. And this is very good because 3 times 4 is 12. Then I can replace it by this. So I can replace this by 12 to the power of 1 over 2. And then we have these other two terms, 3 to the power of 3 over 8 times 4 to the power of 3 over 8. So again, I can write this, maybe I can use this color. I can write it as, well, 3 to the power of 3 over 8 times 4 to the power of 3 over 8. So I can write it as 3 times 4 to the power of 3 over 8. So I can write this as 12 to the power of 3 over 8. Now I can simplify the whole expression, or actually the expression on the left hand side of the equality sign, and write it as, well, we have 3, well, we keep this, we replace this one. So it is 3 to the power of 1 over 4 times 3 to the power of 1 over 8 times 3 to the power of 1 over 16 times 3 to the power of 1 over 32. And in denominator we have 12 to the power of 1 over 2 times 12 to the power of 3 over 8. And this equals this expression, 3 to the power of 8 times 3 times 12 to the power of b. All right, now here we have 3 to the power of 1 over 4 times 3 to the power of 1 over 8. I mean, you see that the bases are the same, the exponents are different, so we can apply rule number 2. And we can just sum up all the exponents. Then I need to write one of the bases. Okay, here. Write one of the bases and then sum up the exponents. That means we can replace this expression in numerator by 3 to the power of something. And this is very good because that's what we were looking for. And for that, again, I need to add up 1 over 4 to 1 over 8 to 1 over 16 and to 1 over 32. So let's do it here. We have 1 over 4 plus 1 over 8 plus 1 over 16 plus 1 over 32. And this equals, well, I need to find the least common denominator between 4, 8, 16, and 32, which is 32. And we know that 32 has 8, 4 in it. So I should multiply this by 8. Then we get 8 here. If I do so, we get 4 here. Then we get 2 plus 1. Okay. This gives us 15 over 32. What does that mean? That means I can replace the whole expression here by this, and then replace this by 3 to the power of 15 over 32. So let me get rid of this. (15/32), so I'll keep that in mind. So this equal, I mean the whole expression here, I can write it as 3 to the power of 15 over 32. All right. And then for denominator, we have 12 to the power of 1 over 2 times 12 to the power of 3 over 8. That means, again, following the rule number 3, we can keep one of the bases and then sum up the exponents. Then I'll get 12 to the power of 1 over 2 plus 3 over 8. So if I just add up these two, then we get 4 over 8. I can write 1 over 2 as 4 over 8 plus 3 over 8. This is 7 then. 7 over 8. That means I can replace the whole expression here first by this, and now I can replace that by 12 to the power of 7 over 8. Okay. Over 12 to the power of 7 over 8. And we know from rule number 4, we know if we have 1 over a to the power of n, this equals a to the power of minus n. So I can take this denominator up, all right? Then I can write this as 3 to the power of 15 over 32 times 12 over 12 to the power of minus 7 over 8. Okay, now if I, well, this is exactly what we were looking for. Okay, we were looking for something in the format of 3 to the power of a times 12 to the power of b. That means this 15 over 32 is a and b is minus 7 over 8. So this is a and this is b. So I can write here, or let's say here, well, we know a is 15 over 32, b is minus 7 over 8. So if I sum up these two, I'll get 15 over 32 plus minus 7 over 8. So I can directly write it in this format. Then we need to find the common denominator between 32 and 8, which is 32. We have 15 here, and here we actually multiplied 8 by 4 to get 32. We need to multiply 7 by 4 as well. So it is minus 28, and this equals minus 13 over 32. And this is the final answer. So this is actually a plus b. And you are done.